The pneumatic system uses air from the engines to supply the following systems: air conditioning system, pressurization system, ventilation system. In this module, we will focus on air conditioning, avionics, ventilation, and pressurization. The air conditioning system is supplied by air, processed through two pressure air conditioning kits, packs, which regulate airflow and temperature as required. The two packs are installed in the main landing gear fairings and operate automatically and independently. Air conditioning is controlled, monitored, and regulated by MFCs. The Pack 1 supplies cabin and cockpit, 1/3 airflow for cabin and 2/3 airflow for cockpit, with conditioned air. The Pack 2 only supplies the cabin. Hot air from the engines is admitted into the packs through the pack valves. The pack valves are electrically controlled and pneumatically operated. If one pack is inoperative, the other one supplies both compartments through the mixing chamber. Two recirculation fans are installed under the floor, connected to the mixing chamber to homogenize the temperature inside the cabin. The air inlets are located on the engine air intake, on main landing gear fairings, and in a dedicated external ground unit connector located on the right main fairing. An air conditioning ground connection access door enables cabin to be conditioned during ground operations. The air is conditioned by the pressure air conditioning kit, packs. The air bled from engine compressors is controlled in pressure by a pack valve before entering into the conditioning unit. It is then pre-cooled by an air heat exchanger and routed to the pack. The function of both air conditioning packs are to limit the airflow into the pressurized compartments, taking into account the pressurization system performances, to cool the bleed air down to the selected temperatures, to remove condensed water in order to maintain an humidity level matching with passengers and crew comfort. The required cooling energy is provided by air-to-air heat exchange and expansion of compressed air. Cabin exhausts through the outflow valves. Avionics ventilation exhausts by the extract fan through the overboard valve, located under the front belly of the plane. The temperature control system controls automatically and manually the flight compartment and cabin temperature. The Pack 2 regulates cabin temperature, and the Pack 1 regulates flight compartment temperature. A pack airflow control push button enables airflow selection between normal and high flow. It enables to increase airflow in the pack in order to improve cooling efficiency. It may be associated with engine power increase. In normal operation, both bleed valves supply their own pack to condition the aircraft, and both recirculation fans are on. In automatic mode, the temperature is adjusted and regulated by the temperature control valve. In flight, To check and adjust cabin temperature, crew must select compartment selection switch on cabin position. Then the crew adjusts the cabin rotary selector in the desired position. In manual mode, the temperature is adjusted by a direct temperature control valve action, using the associated rotary knobs. In case of single pack failure, the remaining pack will supply both compartments through the mixing chamber. Air pack is displayed in amber on EWD. Local alert is displayed on SD cabin page in ACCP panel. In case of recirculation fan fault, master caution and single chime are triggered. Air recirculation fan is displayed in amber on EWD page. Local alert is displayed on SD cabin page in ACCP panel. The air ventilation system provides cooling of the electrical and electronic equipment through ambient air extraction, to limit the internal equipment operating temperature. Ambient air is blown around the instruments, DUs, the central panels, the glare shield, the pedestal and the windshield temperature controller, and goes through ducts to the extraction fan. Extract air flow prevents smoke entering the flight compartments from other compartments. Behind the extraction fan, a tapping brings air to ventilate the batteries. Remaining airflow is evacuated through overboard valve or underfloor ventilation valve, depending on flight conditions. System is fitted with temperature sensor and many smoke detectors. The avionics ventilation control panel is associated with a SD cabin page. An overboard valve manages, in auto mode, the underfloor valve position. When overboard valve is closed, underfloor valve is opened and vice versa. On ground, with engine 1 not running, extract fan runs continuously, overboard valve is full open to exhaust ventilation air, and underfloor valve is closed. In flight or on ground, with engine 1 running, overboard valve is closed and underfloor valve is opened. Ventilation air is recirculated inside the cabin. Exhaust mode push-button fault illuminates in case of any extract fan failure. Air ventilation exhaust is displayed in amber on EWD. During engine start sequence, the extract fan stops for 120 seconds with associated fault indications. The central fault light indicates an overboard valve disagreement and activates the FWS. Air overboard is displayed in amber on EWD, meaning that, on ground with engine 1 not running, the overboard valve is not fully opened. In case of failure, the overboard valve can be manually switched on full open or on full close positions. The extract air flow lever isolates the flight deck and prevents smoke from the forward cargo compartment to enter the flight compartment. The normal position of the extract air flow lever is open. The extract air flow must be closed only in case of forward compartment smoke. The cabin and flight compartment are pressurized to ensure comfort and safety for passengers and crew. Cabin pressure is increased by air delivered by the packs and is regulated via 2 outflow valves. One outflow valve is electro-pneumatic and the other one is pneumatic and slave to the first one. To prevent any abnormal cabin pressure, over and under pressure, 2 safety valves are fitted. Auto pressurization panel is located on the central panel. Cabin SD page is used to control pressurization data, delta P, cabin altitude and cabin rate. For pressurization regulation purposes, it is necessary to enter the landing airport elevation. It is manually set on the auto press panel using the associated switch. Takeoff elevation is memorized in the system until passing 3,500 feet above airport elevation in climb. Value for cabin rate in climb is around plus 550 feet per minute. Cabin rate in descent is in normal mode, minus 400 feet per minute, in fast mode, minus 500 feet per minute. In case of auto press fault, master caution and single chime are triggered. Mode sail fault illuminates on cabin pressurization panel. Air auto press is displayed in amber on EWD. In manual mode, a rotary knob is located on the cabin pressurization panel and will manage the cabin rate. In case of cabin altitude between 9,500 feet and 10,000 feet, cab alt is displayed in amber on EWD. In case of differential pressure between 6.25 psi and 6.6 psi, or between minus 0.2 and minus 0.5, cab delta P is displayed amber on EWD. Excessive cabin delta P occurs when a differential pressure is above 6.6 psi. Master warning and continuous repetitive chime are triggered. Excess cab delta P is displayed in red on EWD. Excessive cabin altitude occurs when cabin altitude is above 10,000 feet. Master warning and continuous repetitive chime are triggered. Excess cab alt is displayed in red message on EWD. Negative differential pressure occurs when cabin delta P is below -0.5 psi. Master warning and continuous repetitive chime are triggered. Negative cab delta P is displayed in red on EWD.